Morning, each and everyone. Here we are there to present our project for the final TARP review. Our project is discussing more about a remote telemedicine system which we have created using machine learning algorithms. We have created this system using and verifying various research papers and coming to a conclusion that how to improve the old methodological research learnings to improve new modernization techniques. People in past have used logistic regressions and SVMs as the best machine learning models which have been available throughout the market. But in the recent future advancements, Facebook, Google, Amazon have came up with new algorithms which are more and what we say more better, more quicker, and more responsive. The boosting technology and the niche of the Genie method have been improvised such that the random forest classifier, XGS boosting, gradient boosting have been theoretically providing more accuracy and more better performance than the previous old traditional logistic regression and SVM for classification of any data set. So for this majorly in this project, we have been using few sites for gathering the data sets such as Kaggle to gain the data set all around the peoples for the major diseases such as cardiovascular disorder, heart attack, and what do you say, diabetes and breast cancer. The reason behind choosing these four diseases was pretty clear. These are the most prevalent diseases in India. Since we are focusing currently on our country and we want to grow ahead, so that's why I have chosen the most prevalent. We have chosen the most prevalent diseases in India. So let me just share our project. So basically, this is our web page which we have created for our users. To know more about us, these are the team members: Dhruv Parekh, Ankush, Arjun, Marin, Jigyas, Tanmay, and Riya Singh. The main four diseases, as we already stated, are diabetes, breast cancer, cardiovascular disorder, and heart attack. The main mission of our project is named as Code Red. Our tagline is Your Health is Our Mission. We are trying to help each and every individual who are facing to these prevalent diseases to diagnose in a better manner. We started by reincarnating the systems which have already been created and worked on in different various research papers. This was our first prototype model of logistic regression. As you can see, we have chosen our heart attack database. We have taken the data set. We have applied logistic regression. We have applied the machine learning part here. Then we split the data set because in machine learning, if you don't split the data set, it's of no use. Basically, we have split our data set into various parts such as training and test. So in test dataset, it will test after learning from the machine learning model. And in the training dataset, it starts to learn and fit the data according to the system. We have found the accuracy. We have given the SC confusion matrix and the classification report of our system of a particular diseases through heart attack. The outputs of the same can be visualized here. We have gained 76% of accuracy, and we have chosen these factors as our main part, and this is the confusion matrix for the model. Then similarly for the cardiovascular disorder, we have chosen a dataset from Kaggle which was having a high usability of 8.5. Then we removed the factors which didn't have an impact by explorative data analysis, and then we led to the same logistic regression model, and we gained an accuracy which was of 71.6, with the higher precision values and support followingly. Then we went ahead to the breast cancer. Since we got the best data set from UCI, we were easily able to manage a 93% of accuracy with one precision which is highest and the support of 90. Moving forward to diabetes, similarly, our outcome gained to 73% of accuracy. Now, after learning these all things, we just came to a point that why are people shifting from logistic regression to new modern technologies of random forest classifiers and XGS boosting and gradient boosting? The old previous logistic regression works on a sigmoid function. This is a function which is used for gradient descent. What this function does is it fits the model in such a way that it all the parameters are required to fulfill the current situation and gain a final analysis of the report or anything which we need all the factors to give the model answer. Whereas XGS boosting, random forest classifiers and others are certifying in better manner by using Gini index factor. In this particular case, there is a probability index for each and every factor. The main factor is chosen at the topmost and dividingly all the whole tree follows. Even if there's one missing factor, the second weak forum will be chosen and the whole model will work still. So that's why people have started shifting from the standard logistic regression to random forest classifier. Here's the random forest classifier. Same here also we have used the same data set so that we gain an access and knowledge to how this grow. We have successfully achieved 84% of accuracy in our heart attack model, whereas we had just gained 71% in our previous heart attack model. Similarly, for the cardiovascular disorder, we gained 70%, though it is at par of the logistic regression. For breast cancer, we have attained the highest ever recorded accuracy of 97.2%. For diabetes, we have recorded 79.6% of accuracy. There is an old myth going around in the machine learning language world that support vector machines are the best format of choosing or classifying any data set with a supervised learning. But after our research and after our supporting algorithmic outputs, we came to a conclusion that on some factors, even the logistic regression is classifying better than SVMs. Because we got 71% of accuracy on logistic regression, where we leaded to 68% only in SVM. Similarly goes for cardiovascular disorder. It gained 71.5%, which was at par to our logistic regression and random forest classifier. In breast cancer model, it performed a little bit poor with 92% of accuracy. In the diabetes model, we had a result of 76% of hike, which was a fair enough, reasonably higher than our random forest classifier. There might be a reason that random forest classifier didn't perform well because that there will be a low amount of data set. SVMs are best when it comes to a small data set, whereas random forest classifiers are appropriately good in a medium size of data set. To rectify this error, we went with one more type of algorithm, which is known as gradient boosting. In gradient boosting, to a surprise, we didn't perform pretty well as compared to random forest classifier. We gained 76% of accuracy. In cardiovascular disorder, we again gained 73% of accuracy, which was at par more higher than all the other models which we have performed before. In cancer model, we attained the accuracy of 95%, which was at par to our random forest classifier, though random forest classifier has an edge over this model. The diabetes model showed a weird phenomenon by gaining the highest amount of accuracy of 79% by providing us the best performance on gradient boosting. Our fifth model was XGS boosting. To our surprise, though it is considered as the best model, it gave us 71% of accuracy due to one issue of log loss. Since we have been appearing on logarithmic values in diabetic models in float value integers, the diabetic model didn't support it well. Thus, it gave us the accuracy of 71.8. Whereas all the other models, such as breast cancer and others, provided the equal amount of quality of 96%, 73, and 85.5. Heart attack model was given the best accuracy in XGS boosting model. So, coming to a conclusion that this all part is only learned and performed by the engineers or the coders or the developers. What about the common public or the end users? Here comes our best part of the library called tkinter. We have applied our machine learning codes into tkinter by providing them a best accurate results and showing them how their original life can be occurred and easily they can predict the whole results. As you can see, by running my heart attack analysis model, we can directly print out a screen where a common person can write and fill up his form to gain his knowledge and attain the values which he or she might be acquired of. Before coming to this part, I would like to bring light upon a fact that after running 25 different models, different algorithms on each and every diseases, we came to a fact that for diabetes, gradient boosting or random forest classifiers are providing us with the best accuracy of around 78%. Secondly, for breast cancer, random forest classifier algorithm was no doubt an ubiquitous winner with a 97.3% of accuracy. The cardiovascular disorder had seen a lower side, but in gradient descent and gradient boosting algorithms, it gave us 73.28% of accuracy, whereas to the surprisingly part of an heart attack model, XGS boosting classification algorithm, as we have previously seen, provides us with 85.6% of accuracy. Here, now I want to take forward to our GUI model, which we have been prepared through tkinter, and this is how the model looks ahead. So let's just start with this. My name is Dhruv. My age is 21. My gender is male. Chest pain type 3. Pressure 120. Serum cholesterol 2. Fasting blood sugar 118. Electrocardiograph 89. Maximum heart rate again 92. Exercise again 2. Safe depression 1. Step 1. 0. Heart rate 72. Just a second. I'll rerun the program. For the cardiovascular disorder, let's just fit in the details. Okay, so let's start with this. Centimeters. 20. One. Small 0, or 0. I do regular activities, and here's the chances of my cardiovascular disorder. And here it comes the outcome. It shows that I have lower chances of cardiovascular disorder if my report suggests this. So this is how we came to a point that after showing them a visual effects of the machine learning algorithm and giving them real life outcomes. And this is the accuracy of the models. Going ahead with the diabetic model. For diabetes, again, we will store our data in the name of age 21, gender 1, pregnancy 0, glucose 5. So this is what my diabetes model shows, that I have a lower chances of diabetes. Similarly, if I just change some values to just depict that, it gives the higher perspective as well. If I change this to 1.25, body mass index to 45, insulin to 10, skin thickness to 45, blood pressure to 222, glucose to 5, pregnancy 0, and this is how our whole model works. And this is our breast cancer model, where we have attained 97.2 degrees Celsius percentage. These are the factors which we have taken in choice: radius of mean, texture mean, perimeter mean, area mean, smoothness, and different factors for getting a best result. And we have attained one of the best scatter plot and the heat map of the classification matrix. The future scope which we are planning to work ahead for this project was to gain an online server by CGI Python, and we have created some online forms such as a GUI we can attempt online through our model and our website. So this is the form where the person can fill his age, its gender, chest pain type, the resting room, hernia type, slope of depression, slope of major vessel, roughly 0, heart rate 83. And as soon as it submits the report, it will be shared and our machine learning model will give them the right outcome. So this is our whole project and our future prospectus where we are moving ahead and taking this project to the next levels and next categories. Thank you. I hope you all liked our project and appreciate us for the same. Thank you. Thank you everyone.